Hello students, today in this video we are going to see how to evaluate integrals using Cauchy integral formula and Cauchy residue theorem in complex analysis. I am going to do a problem using both the methods, Cauchy integral formula as well as Cauchy residue theorem. And this is the problem. We are going to evaluate using Cauchy integral formula as well as Cauchy residue theorem for evaluating the integral over c z plus 1 by z squared plus 2z plus 4 dz, where c is the circle, modulus of z plus 1 plus I equal to 2. First we have to find what is the center of the circle and radius. Obviously radius is 2. Center, we can generally, the equation is of the form modulus of z minus a equal to r. So here the radius is 2. We have to find what is a. So modulus of this, the given equation, no, we can rewrite as minus sign varanum. So the given term I am rewriting as minus of minus 1 minus I equal to 2. So minus a தான் நம்மளோட general format. So common ரெண்டு termல இருந்தும் நான் minus sign வெளியில எடுத்துறேன். So minus into this will become minus and this will become minus. Minus 1 minus 1. Okay, so now the center is what? Minus 1 comma minus 1. Actually the value is minus 1 minus I, no. So I am converting that as a point, writing the coordinates x coordinate comma y coordinate. So minus 1 comma minus 1. So with center minus 1 comma minus 1, the circle is with radius 2. Where minus 1 lies? This is my minus 1 comma 0 and this is 0 comma minus 1. So here the point lies minus 1 comma minus 1. So with this center, with 2 units means 1 2 here and here 1 2, like that it will go down on this side. We have to take a circle, it will like come like this, right? So this is a circle. So we have located the center and the radius is 2. So after calculating the poles, we have to confirm which pole lying inside and outside. Okay, based on that we have to proceed. We are going to find the poles. How to find the poles? Taking the denominator equal to 0, finding the roots will give the poles, right? Z squared plus 2z plus 4, which is equal to 0. Directly we are not able to find the roots. So we are going to use the formula minus b plus or minus root of b squared minus 4ac by 2a. Am I right? So a is equal to coefficient of z squared, that is 1. B is equal to coefficient of z, that is 2, and c is equal to the constant term 4. Therefore, z is equal to minus 2 plus or minus root of b squared, that is 4 minus 4 into a into c. So 4 into 1 into c is 4. 4 4s are 16 by 2 into 1, that is 2. So minus 2 plus or minus, when we we will get a negative sign, minus of 12 by 2. For this negative sign inside the root, minus root of minus 1 is equal to I. Is it? I squared is equal to minus 1. Taking root will give root of I squared is equal to root of minus 1. So I is equal to root of minus 1. Yeah, that only we used here. So for this minus 2 plus or minus, for this negative sign inside the root we can take one I, and root of 12 can be written as root of 4 into 3. For this 4 we can take 2 outside. Inside the root it is 4. When it comes outside it is 2. So 2 into root 3. So it is 2 into root 3 by 2. Okay, both the terms are having 2 common, so I can take the 2 outside. So 2, this is minus 1 plus I root 3 whole divided by 2. So 2 we can cancel. So the poles what we are getting is minus 1 plus I root 3 minus 1 minus I root 3. These are the poles what we are getting. I am going to name the first one as Z0 and this as Z1. These are the poles. Okay. So which pole lying inside and which pole lying outside, that we have to confirm. This is a circle, this minus 1 comma minus 1 with 2 points. We have taken a circle, no, right? What is the radius of the circle? Radius is equal to 2. Okay, if a point lying inside, for example, if this point lying inside means the distance between the center and the radius, obviously it should be lesser than 2. நான் என்ன சொல்கிறேன் புரியுதா? இப்போ இந்த சர்க்கிள்குள்ளே ஒரு பாயிண்ட் இருக்குது அப்படின்னா இந்த சென்டர்லேருந்து அந்த பாயிண்ட்டுக்கு நம்ம டிஸ்டன்ஸ் கேல்குலேட் பண்ணணும்னா கண்டிப்பாக அது அதோட ரேடியஸ் 2 விட லெஸராக இருக்கலாம். இல்லை ஃபார் எக்ஸாம்பிள் இப்போ இந்த சர்க்கம்ஃபரன்ஸ் மேலே இருக்குது, சர்க்கிளோட சர்க்கம்ஃபரன்ஸ் மேலே இருக்குது அப்படின்னா 2க்கு ஈக்குவலாக இருக்கலாம். 2 விட ஜாஸ்தியாக போயிடுது, கிரேட்டர் தான் 2 ஆயிடுச்சு அப்படின்னா obviously that point lying outside the circle. That is the concept what we are going to use for checking whether the point lying inside or outside. நான் ரிப்பீட் பண்ணுறேன், சென்டர்லேருந்து இப்போ ஒரு பாயிண்ட் அந்த சர்க்கிள்குள்ளே இருக்குது, இது வரையும் மேக்ஸிமம் எடுத்துக்கலாம், சர்க்கம்ஃபரன்ஸ் வரையும் இது வரையும் இருக்குது அப்படின்னா இது ரெண்டுக்குள்ள டிஃப்ரென்ஸ் கண்டிப்பாக நம்மளோட ரேடியஸ் 2 விட லெஸராக ஆர் ஈக்குவலாக இருக்கலாம். 2 விட ஜாஸ்தி ஆகிடுது, கிரேட்டராக ஆயிடுச்சு அப்படின்னா obviously that point is lying outside the circle. So that concept only we are going to use for checking whether these two poles lying inside or outside. Okay, so for that what I am going to do is I am going to find the distance. Let the radius be a. What is the radius we got? Minus 1 minus I. That is the radius what we got. Minus 1 minus I. So we are going to find the distances z0 minus modulus of z0 minus a and modulus of z1 minus a. These two distances we are going to find, and if the difference between these 2 points, that is distance between these 2 points, is less than 2, that lies inside. If it is greater than 2, that point lies outside. So modulus of z0 minus a. What is z0? Minus 1 plus I root 3 minus a is minus 1 minus I. Modulus. Why we are taking this modulus? We are calculating the distance, only the magnitude we have to take. Okay, so for that modulus, which is equal to modulus of minus 1 minus of minus plus 1, so it will get cancelled, right? And in the I part it is I into root 3 minus of minus plus I. So both are having I common. I can be taken out, 1 plus root 3. So what we have here is, later I will write, modulus of I, modulus of 1 plus root 3. What is modulus of I? Modulus of I is 1. The mod value of I is 1. The mod value of minus I is also 1. Okay, so modulus of I is 1, and only you have to calculate modulus of root 3 plus 1. What is root 3? Root 3 is equal to 1.732 something, right? So when we add 1 to it, obviously that is a value which is 2.732. Obviously this is greater than 2. So this distance between z0 and a, when we calculate, no, we are getting a value which is greater than 2. Greater than 2 means this z0 is lying outside. So this z0 is lies outside. So when we use Cauchy residue theorem, no need to calculate the residue for this pole. Okay, no need to calculate for this pole, only for z1. If it lies inside means we have to calculate for this. Okay, so let me check whether this z1 lying inside or outside. So for that I am going to calculate modulus of z1 minus a. Modulus of z1 minus a. z1 is minus 1 minus I root 3 minus 1 minus I root 3 minus of a is minus 1 minus I, which is equal to minus of minus plus. So minus 1 plus 1 will get cancelled. This is minus I root 3 minus of minus plus I. Both are having I common. So 1 minus root 3. This is equal to modulus of I into modulus of 1 minus root 3. Modulus of I is 1. 1 minus root 3 means 1 minus 1.732 something. So when we subtract, obviously it is a value 0.732, which is lesser than 2. Lesser than 2 means z1 lies inside. So for this only we are going to calculate the residue, and using Cauchy residue theorem we have to find the integration. Okay. This is Cauchy integral formula 1 by 2 pi I integral over c f of z by z minus z naught dz is equal to f of z naught. So first we are going to use Cauchy integral formula, then we will use Cauchy residue theorem. So the formula is equal to, actually 1 by 2 pi I we are not having in the problem in this side. So we can multiply this 1 by 2 pi I to the other side. So integral over c f of z by z minus z naught dz. நமக்கு ப்ராப்ளம்ல கொடுத்ததுல 1 by 2 pi I இல்லைன்றனால நம்ம cross multiply பண்ணிக்கிறோம் 1 by 2 pi I. So f of z naught. So f of z naught என்றது நீங்கள் எந்த போல் வச்சு calculate பண்ண போறீங்களோ அதுதான் we are taking. Okay. நம்ம இந்த போல் தான் lying inside சொல்லியிருக்கோம் z1. So for this only we are going to start, we are going to do our z1 is minus 1 minus I root 3. So minus 1 minus I root 3. Okay. So the given problem I'm going to take, this is the problem given, no. So we have to write integral over c z plus 1 by this one we have factorized, no. What are the factors we got? What are the poles we got? Minus 1 plus I root 3 minus 1 minus I root 3. So we are going to write is that generally we get two roots, means we can write the factors as z minus z naught into z minus z1. Like that I am going to take z minus, first z naught value we got as minus 1 plus I root 3. So minus 1 plus I root 3. This minus is common into z minus, the second term is minus 1 minus I root 3. So minus 1 minus, put a bracket, minus I root 3. So originally the problem given is this one, z squared plus 2z plus 4. We got the two roots, these two, no. So we have factorized z minus minus 1 plus I root 3, z minus of minus 1. This is actually z minus of minus 1. So second factor is minus 1 minus I root 3, no. So minus 1 minus I root 3. Okay. So for which pole we are going to calculate z1? For this only lying inside, no. So for this only we are going to calculate. So leaving that factor, take all the terms as f of z, these terms. Okay. So here f of z is equal to z plus 1 by z minus minus 1 plus I root 3. Because in the formula we have to calculate what is f of z naught. Don't confuse z naught and z1 here. Oh, actually this is Cauchy integral formula. Since already we have used z naught and z1 here, no. I will change this formula, this notation, because in the formula we have no z naught, z1 don't use. Let these values be z1 and z2. So this is z1 and this is z2. So z1 and this is z2. So z2 only lying inside. For this only we are going to calculate. So z2 only we are going to calculate, and this is the formula. So for this only we have to take f of z naught. Okay. This is our f of z. So for which pole we are going to calculate? Minus 1 minus I root 3. So that z has to be replaced by minus 1 minus I root 3. So when we substitute, it is minus 1 minus I root 3 plus 1 by minus 1 minus I root 3 minus of minus 1 plus I root 3. You have to simplify this. These two will get cancelled. So which is equal to minus I root 3 by minus 1 minus into minus plus 1. These two will get cancelled. Minus I root 3 minus plus minus. So minus 2I root 3. I we can cancel, root 3 we can cancel, minus we can cancel. So finally we have 1 by 2. Okay, so what is the formula we have? 2 pi I into f of z naught. So 2 pi I into 1 by 2 we got, no, 2 we can cancel, and the answer is pi I. This is using Cauchy integral formula. The same problem we are going to work using Cauchy residue theorem. Okay, what is Cauchy residue theorem? Integral over C, the given function into dz is equal to 2 pi I into sum of the residues. But here we are going to calculate residue only at this point. Minus 1 minus I root 3, since this one lies inside. For this only we have to calculate the residue. So this is the function given, and at this pole we are going to calculate the residue. We are going to use this method, h of z by k of z. What is the residue formula? Residue of f of z at the pole minus 1 minus I root 3 is equal to, what is the formula? H of at this pole minus 1 minus I root 3 by k dash of minus 1 minus I root 3. This is the formula, so which we are going to use now. So for that, first we have to find what is k dash, right? So k of z is equal to z square plus 2z plus 4. So k dash of z is equal to 2z plus 2. K dash of, what is z value we have to take? Minus 1 minus I root 3. Minus 1 minus I root 3, which is equal to 2 into minus 1 minus I root 3 plus 2. Minus into plus into minus minus, and this is plus. So both will get cancelled. Minus 2 root 3i. That is my k dash of minus 1 minus I root 3. I have to calculate what is h now. H of minus 1 minus I root 3. H of z is equal to z plus 1. So minus 1 minus I root 3 plus 1, which is equal to plus 1 minus 1 will get cancelled. So minus I root 3. So both the terms we are going to substitute here, which is equal to this is minus I root 3 by, and this is minus 2 root 3 I. Root 3 will get cancelled, I will get cancelled, and minus minus will get cancelled, and it is 2 pi. And 1 by 2. That we have to substitute here. Only one residue we have now. So 2 pi I into 1 by 2. 2 is getting cancelled. So answer is pi I. This answer only we got using Cauchy integral formula, pi I. The same answer we are getting using Cauchy residue theorem. Is it clear? Thank you.